Hello everyone. So today we will discuss about HA Daemons. Okay. So as you see, this is the HA advanced architecture. So as we know that, so in Palo Alto we have a separate management plane and data planes. Okay. So see, in the management planes there is two daemons working in HA. One is system D and second is HA agent. Okay. So system, this one is a firewall one, and this is firewall two. Okay. So this one is firewall two and firewall one. So system D of firewall one and system D of firewall two is communicating these TCP ports through HA1, through HA1 link. Okay. And this is communicating from this direction with this port through HA1 link, and in direction also one TCP connection is stabilized on by using these ports through the HA1. Okay. So in HA1, as we know, through the HA1 we have share some details, exchange the details from firewall one active to clear. Okay. So these are heartbeat, hello message, and config sync. Okay, what you have configured in the firewall one, and this is firewall one is in active mode. So what you have configured, they sync all this configuration through HA1. Okay. So the function of system D is only to manage some daemons. Okay. Multiple daemons are using the firewalls in Palo Alto. So by using the HA library, okay, through the HA library, multiple like user ID, cache, fib table, DSCP lease, FQDN, and DNS, all these caches are refreshed. Okay, so every parameter, every user ID is managed by the user daemon. Fib table is driven by MP relay. DSCP managed by the DSCP daemon. So multiple daemon for every functions have a separate daemon working in the Palo Alto. Okay. So all these multiple daemons through the HA1 library, these are managed by the system daemon. So they are not directly communicate with the system daemons. Through the HA library, they are managed by the system daemon. Okay. And agent, HA agent. So HA agent is used to sync by using this 28769 TCP ports. They have just exchange, okay, they exchange heartbeat and hello message. Okay, state, HA states, all these things. And raw connection means they have just sent the ICMP packet from active to passive, and they have, if the ICMP response is not getting from any breaks and not getting any response, then the peer device, the device is thinking the peer is not working. So they have just take a role of active. So then we have HA1 backups managed by the HA agent daemons. So by using these ports 28770, they have managing HA1 backup. And if we have we are using HA1 and HA1 backups, and one option is also there through the management ports, you have just exchanged that heartbeat and hello message. So for that, we use TCP 28771 okay, to exchanging the heartbeat and hello message through the management ports. So these are these daemons in management plane. In the data plane, they use HA2 to exchange the session seek, providing tables, up tables, all this exchange through this HA2. Okay. So for HA2, we are using by default Ethernet connectivity. Okay. So it is a L2 connectivity. You have directly connected through the Ethernet. Okay. And then that is use Ethernet ports 0 into 7261. Okay. If there is a L3 connectivity between HA2, okay, they use IP protocol 99. Okay. And in the AWS environment or Azure environment, they use UDP 29281 port, UDP ports. So in the data planes, they use PAN DHA, PAN DHA Daemons. Okay. So all this managed by the PAN PAN DHA. Okay. So I'm just going to open and you have to show you uh, for these things. We have a multiple so this one is currently active and this is passive. So I'm going to open this one. So this one is active. So I'm discussing about multiple daemons are working in the Palo Alto. So let me show you. So system, software, status. See, all these are the daemons and the running is state is running. Okay. See, these are the all daemons. So DSCPs, this one. So all these daemons managed by through the system daemons. Okay. Then we have talked na so see this TCP port 28260 and 28769. Okay, so I am opening uh, show you how it establishes the connection between the system D and to system D by using the bidirectional TCP port 28260 and one is this one TCP. So let me show you one commands. Okay. So see, I'm first of all the my H Ethernet 1/3, and this is the IP of this one, and there is a passive side this one IP. Okay. So let me show you. There is a one command so net stat. Okay. Then just this one, and then there is other कैसे numeric. Okay, numeric, and then you write yes and question mark, then enter the values. Okay, so my HA1 value, HA1 IP is 1.1.1.1 and then enter. Okay, so yes, yes. Continuous 10 fib group interfaces, numeric route, static, symbolic. Stat. Okay, yes. Okay, and then there is a match, I think. Let's say okay, let me check that command. I'm a little bit confused. Yeah, yes. This one is pipe. Okay, just pipe, then match, and then you just give the IP of HA1. Okay, so just see. So this port one, this 2 at 769. And so this is source. Okay, so peer uh, firewall 2 is initiating this connection. Okay, so 2 at 769, and there is see 2 at 260 and 2 at 60. So they have two connections, bidirectional connection with this TCP. And there is a row. So through the row, they have just shared the ICMP ping sending. Okay. So this one is 18560 and they have TCP connection stabilized. Okay. So see, one is 2 at 769 and two connection by using the TCP port 2 at 260. So let me take a packet capture. Okay. So these are, let me show you second one. So this one is the HA1. Na? We have just run the HA2. One dot. So this one they using 2 at 770. Okay. And they use ICMP. So see, as per diagram, see in HA1 backup, so they use TCP port 28770. Here they use this one. Okay. When you using the management, they use, if you use the management port for the exchange heartbeat and hello message, they use 28771. Okay. So you will see this. So let me take a packet capture. Through the packet capture, I want to show you. Before packet capture, I'm just try to log in my EVNG lab to allow to take the packet capture. So let me open that. So now I am taking the packet capture for HA1. HA1 is by using 1 by 3. See, they are kept using this port 28260. Let me stop the packet capture. See, they send the ICMP echo request and reply. So they're sending the ICMP ping to find the peer device is alive or not. Okay, and then they use 28760. Okay, so this one is source is this one, and peer device source they send this one from this source port to this destination port 286. Again, the peers is sending the local device by using this. So they have used the bidirectional communication with this port. Okay. And for the second one, this where is that port 28769? You have also see this one 28769. So they are using to exchange the heartbeat, hello message, and sync configs. So by using this one, they have set up the TCP connection. Okay. Now I'm going to connect, take a capture for the HA1. HA1, HA1 backup. So just going to, so HA1 backup is running on with Ethernet 1 by 4. See, 2 at 770. They communicate with this port 2 at 770 and also send the ping packet. Okay. So this one is HA1 backup. Now I am going to take a packet capture on HA2. So my HA2 is Ethernet 1 by 5. So let me take a packet capture on this. So this one is the data synchronization. So let me generate some data. Okay. So see, in my scenario, management port is not enabled. So heartbeat backup is not configured. That's why I'm not taking a packet capture for the management. So when you, management is on, then you see the communication with this port 28771. Okay. So just this one. Okay. See, it's sending the gratuitous art request and reply. Okay. So this one is I'm taking the packet capture on HA2. So see, my connectivity for the HA2 is Ethernet type. So see that this Ethernet protocol is using the 0 into 72662, this one protocols. And they sending the graduates are for these ones. Say broadcast for this 3.2 and reply with these two. Okay. So I know I am also generating some traffic. So you can let me generate some traffic. Okay. I'm just in this one and also facebook.com. So we are using this through the LAN PC. We are just initiate the traffic. Okay. The live session is what we have just set up the live session. They just share all the session sync to the sync with the passive device. Okay. So for that, just I am going to show you that one. Where is that packet capture? Yeah, data. See, so now virtual sharp is not coming continuously because they have shared that session through that HA2 link. Okay. For if you want to check, if I suppose this one is my passive active, let me configure some configuration. Let me create one test object 92.168.200 and 2.168 1.200. Okay, let me just commit and committing that one. So I am just configures on active. Okay. So that configuration is sync on passive through the HA1. Okay. So let me log in the passive device. This is my passive device. I'm just running the one command tail follow as mp log ha agent.com. So see, just wait and wait my commit complete or not. Yeah, it's a 98%. Okay. See, they have commit is completed. Okay. And in the dashboard, you just see synchronization in progress. So they just synchronize with peer device. Okay. So let's see in the see you are just receive the flag from the server and sending the this one. See callback in. See, in the they send the hello message. Okay, in the hello message, they send the all details. Okay. See, there is a MD5. So what you have configured now, they at the active end. So how it know in the peer device it's a config change. So by using MD5, they have just calculate the hashing value, and that hashing value matching at peer side passive device. If passive device hashing value is not matched, then they thinking, oh, some configuration is mismatch. So they have by using the MD5 hash value, they know to know some configuration is changes at active end, active device. See, HA2 MAC address, okay, HA2 backup MAC address. They have syncing all these things. This is the live. This command is used for the live troubleshoot. Okay. So it's already synchronized. So today we learn this HA Daemons, or yeah, let me show you some commands how you can troubleshoot. Uh, Most common commands you are using in the live production environment to see like so high ability state. This command you just check this one. So last this one is the mode of active passive, and this is active last 34 minutes. Okay, and everything is in the peer device. You have just peer information. You also check this one, and second command is all. In the all command, you just check all HA1 and HA2. status and IPs that you configure. Okay, so this one HA1, HA backup, HA2, all these things. And third command, you just want to check HA flap. Okay, if any flap is going in your environment, then you just check flap command through the this command. You check what is the non-functional state flap count resets and preemption flap count resets. Okay, then one command is transition. Okay, so through the transition, you just check how many times your device is suspended, initial, non-functional, passive, active. So the unknown in unknown state, how many times? So through this one, so you just check control link, okay, statics. Okay, just check everything's about the control links, hello messages, failing or any heartbeat breaking, ping is dropping, everything is you are just check from this command. Then you want to check a link monitoring, you just check up or interface is up or not. Any interface is going down, then link monitoring failover trigger. Then you check path monitoring application from this. Yeah. When you check the HA2 keep alive. Okay. So we are not enabled that features. HA2 keep alive is not enabled. Then you check interface. Okay. Interface HA1. So HA1 you just check everything's RX broadcast, bytes, multicast, all these TX bytes, RX bytes. Okay. So if these bytes are received and these bytes are transmit, packet, drop, error, discards, you can just check the real environment. Then HA1 backup. Then HA2. Okay. Then you need to check the session, reinstallation, status, state we have already used. So see this command is used for which purpose? It's in parallel. You just see so HA pair control link static information, flapping static so the high availability pair crimson or non-functional flap statics. So everything HA2 pair keep alive statics, interface information they give, link monitoring states they give, path monitoring statics. This command give the session re-supplies status. It gives the so high availability the pair session re-stabilizement status, the state synchronization. Okay, this one. And you if you through if you want to just failover manually. Then you can check request viability state suspend. Then your active device is now suspended in non-functional. Okay, and peer is going to active, and we have just run functional state functional. Then you check just its local make passive. So in the pass, let's check that commands why it is failover. Then you just run so high high ability all. So in that they that last suspended state region is user requested. So when you trigger failover through the link down, then is showing link down, link monitoring down. If usually failover is triggered through the path monitoring, then it's showing path monitoring. If any to the for the HA region, HA1 link down. So everything is you just what is the reason why it is failed, why it's changed the states from active to passive. So you just check with this command. Okay. So these are the uh, commands we are using in the live environment. So one command is, I'm just opening that less mp log ha agent. Through the h agent, you just check, run these commands and go. Just you copy this and in the notepad you just paste and check what is the region of the failover, what is the actual issue. So by using this command, you just check the issues in the live environment. If you check any, just forward slash and I want to check with active one. You just see the active one, you will see this one is active. If you want to check error, just they give the error, what errors is popping in that. Okay. It will take time. Okay, so one command I also show you uh, for the less less mp log, and if you want to run on dagger log, dsc client log, this is agent, and one is Okay. So these are the commands we are using in the live troubleshoot. So thank you everyone. We will meet in another video with a new topic. Thank you.